All right. Good evening, everybody. Let me start sharing my screen. Do you have any questions from the last class? No questions? Any doubts? Anything that you were stuck on?
No, ma'am.
Oh, no. All right. Okay, fine. So we'll start off with the sixth session today. Just give me 1 second. Okay, so in this week, the lectures were mostly revolving around uh, loops. So we talked about something called conditional statements in the last week. And this week, there's another important. So conditional statements are one of the most widely used types of commands and techniques in R, or for that matter, in any programming language. So that was the if-else statement primarily. And now today we'll talk a bit about some loops. So before we start, this is just some housekeeping things. So before we actually go on to the actual programming, I'll just briefly draw how loops are working. Okay. So generally, what happens is loop means something to be done again and again, right? Multiple times. So let's say a simple thing. In school, we learned about tables, right? A table of, let's say, 2. So you know that you are going from the numbers 1 to 10 and you're multiplying all of those numbers by 2. Or you can say the other way, you have 2 and then you are multiplying that by all the numbers from 1 to 10, and then you want that output. So 2 into 1, 2 into 2, 2 into 3, and so on. So you're doing, so something's constant, but something is also changing. And whatever is changing is sort of fixed. You know what all things are going to be there, right? So that is exactly what a loop also does. So generally you begin somewhere. So let's say this is the start of your loop. And then you say that these are some lines that you need to execute. They could be just one line, they could be multiple lines, but you need to do until, so do this whole step until a condition is like, until a condition stops to meet, right? So now the way you can specify this is different. So we'll talk about two loops today. So one is the for loop and the other is the while loop, right? So we'll talk about the way the condition is mentioned in both of them is slightly different. And also when this thing is changing, you need to tell it. So one thing is whatever you need to execute multiple times. That's the first element. The second element is that condition itself. And the third thing is you need to show what's changing each time, right? Because you can't just keep saying that, okay, multiply 2 with 1, then again multiply 2 with 1, then again multiply 2 with 1. You can't infinitely keep doing that. So that also happens sometimes when you're not specifying what's changing, something stays constant and it just keeps staying constant. You need to get out of the loop, right? So it needs to end somewhere. So that's the basic three things. So the set of conditions, set of statements you will execute or run within the loop. There's a condition that you specify that run it until it's here. And the other thing is what's changing each time. All right. We'll talk about some more things called the next and break. So typically what is going to happen is, let's say if I've drawn all these statements, they'll be running one by, like one after the other. The first line, then the second line, then third, fourth, fifth, sixth, and so on. But maybe somewhere in between, if I had line number 1, and then 2, and then 3, and then let's say 4 and 5. But now let's say if in this line I wrote break. So what it means is the loop is going to go from here to here, from here to here. Normally, it should have gone from 3 to 4, 4 to 5, and then go back to 1 with the new statement. But now, after 3, it's just going to come out of the loop. It's not going to keep going round and round. Break means come out of the loop, right? On the other hand, there's also an option of next. So in that case, you're going from here and then here, and then you skip the next lines and then you go to the next iteration, the next time that the loop is running. So these are jump statements. You're jumping from something to something else, right? And then what nested loop means is that you can have loops within loops. All right. So we'll see examples for all of this. It's definitely a new thing if you have not come across this previously, if you have not had any other programming language experience. But again, please feel free to ask questions or let me know that if something's not clear, and we'll work through it. So that's the main thing that we are going to talk about today. The second thing is we'll also talk about functions. We very briefly touched upon this towards the end of last class, but we'll again do that in detail today. Okay, so this is something we also talked about in the last class. So we've finally come across all these 3 types of brackets that are there in R. So the curved bracket is either when you're talking about mathematical operations, when you have BODMAS and when you have complicated maths, you can uh, have some numbers, some operations within brackets. And then for functions, so this is something we've already been using extensively, right? The curved bracket, you have the name of the function, then the bracket, and everything goes inside that bracket. The second thing, which is this curly brackets, that is used to define chunks. So we saw in the last class what are chunks for if-else statements. So if, and then a set of statements that can be executed if the if condition is true or the else condition is true. Today we'll talk about how we are using chunks with loops and functions. And then the square brackets, that is where we are going to use it to access any one or more indices of vectors or matrices, right? So we've already seen all of this. We'll just see that in more detail today. Okay, so let's start some programming. And I can see more people have joined the session. So do any of you have any questions? All right. If there are no questions, then let's begin the session. All right. So we'll take a couple of examples. So like we said, when you're using a for loop, okay, so yes, so there are 2 loops. So we'll start off with the for loop first. The basic idea of using a for loop or a while loop is very similar. And for most cases, like for a large number of examples, you can either use a for loop or you can use a while loop. It's going to look a bit different. You'll have to write some statements somewhere, but you can use either to do your task. For other cases, sometimes only for loop is a little more convenient. But again, it's a matter of preference. So we'll see both of them and then you can decide which one's more convenient for you. All right. So we'll start off with the for loop. Now you need to start the condition that we are talking about. It needs to be defined in the beginning itself. And generally the condition involves a vector. Okay. So a set of numbers or a set of characters. Right. So we'll take 2 examples. We'll take an example of a character vector also, which is vector 2, and we'll take an example of a numeric vector. So I'm going to run both of them and we can see both of them are executed here. So this is the simplest form of loop. So the way we have written it is, maybe we can write it again. So we write for, and as soon as we have written for, you can see it's R is identifying it as a reserved word. So it's changed the color. And then as is the case for any command, for any function, I'm going to put a curved bracket, curved bracket on this. And inside this curved bracket is where I'm going to write the condition. But outside this bracket, I'm going to start the bracket for the chunk. exactly as we had done for the if else statement. So I'm going to put the opening curly bracket and R automatically puts the ending closing bracket. Now you can start typing it within these brackets. Generally, the condition that you write in the for loop, so which goes in this curved bracket, that's generally very small. So you can write it in the same line. But what goes in the chunk mostly can be in multiple lines, right? So it's a good practice to hit enter at this point. And what you can see here now is that the cursor has shifted a bit to the right. We also saw this for the if statements. So this sort of indentation tells you that now you're within the for loop. Whatever you're writing now is not outside, it's within a certain condition or a loop. It's there's something special about this now. All right, so this is where we are going to start writing the whatever we want to be executed. But before that, we need to write the condition. So let's say I simply want to print all of these, whatever is in my vector 1 or in vector 2, I simply want to output all of them in different lines. Okay. So what I'll do is, um, I'm going to I'm going to use a variable, a new variable that is going to run through each of the elements of this vector. That the name can be arbitrary. So I'm going to call it I, for example. That's a very common I, J, K, L, even A, B, C, D. Generally, people use these counters, but again, the more uh, constructive the name is, the better it can be. You can have a proper word for it. But anyway, so for I, and then I'll write in. Now, in is also a reserved word. So I'm going to write for I in vec1. Now, what this thing means, so vec1, I know vec1 is this. So what's going to happen is, first I will become equal to 10. Then I is going to become equal to 11. Then I is going to become equal to 12, so on and so forth, until I becomes equal to 18. And then I will not have any other option. So then the loop is going to finish. So this is what condition we were talking about, right? You have to have conditions in which the loop runs a fixed number of times. That can be 0 also, that can be 1 also, and that can be a finite number. So in this case, that number is going to be 9. Because that's the length of this vector. Okay, so now I've defined the condition, and inside I'm going to write what to do. For every time that I is a number, I can only ask that you print I. I can do that. I can also say, maybe you print twice of that number, twice of I. So every time you take I, print me double of that number, right? I can also say print hi each time, right? So I can do any of this. So now let's run the whole thing. So again, when you want to run, you can either just have your cursor at the beginning of this line and press enter, like control enter, or you can select the whole thing. Again, both of them do the same task. So I'm going to select the whole thing. I'm going to hit run, and then we'll see what the output is. Okay. So now you can see here what happened is, once this command was executed, I got the output. I got 10, then 20, then high, then 11, 22, and so on. I got a lot of outputs. But you can see that there is a repetition to it. So first I was 10. I got I as the output. I also got 20 as the output. Then I got a high. And then, so the loop was here, then it was here, and then it was here. And then it went up and the value of I changed to the next possible option, which was 11. So I got this option. So on and so forth until I became 18. So once I became 18, then it printed I, it printed double of I, it printed high, and then it went up, but then it saw that there is no other possible value for I. So then it stopped. And then I finally have this greater than symbol showing that I can enter something new. So the loop is over. Does this make sense?
Yes, ma'am.
All right, perfect. So this is how a loop is working, how the for loop. Now we'll just take some examples and make it a little more complicated and see if we are still able to understand that. And then we'll move on to the next thing. Right. So this is, again, I just had an example. That's a very simple one. For this, I like to tell you something else also. So we are talking about this chunk here. The chunk is basically there. It's more useful. It's more useful if you have multiple lines. Like in this case, we had 3 lines. But what if you just have 1 line to execute? So if you just have a single line, you don't necessarily need this curly brackets. So what I can do is I have my cursor here at the end of the curved bracket. I press enter and you see the line has already shifted to the next indentation, right? So it's already identifying that, okay, it's a loop. So I can write print, let's say I here. If I press enter again, you see it's gone back to the original place. Because without the bracket, if once I'm inside the bracket, I'll always get this cursor a bit shifted. But if I'm not in a bracket, then it gets shifted only for the first line. So all in all, if for a loop or also for the conditional statement, the if else statement, if you just have a single line, you don't need the curved bracket. But it is still a good practice to have a curved bracket because it's just a habit that you should develop. But again, once you are more used to all of this, then these rules, I mean, then it's up to you how you want to present your code. All right. So this is also correct. This is also correct. They're both going to do exactly the same thing. All right. So let's do vector 2 in this example. So again, one more thing to note, when I did this, before I ran this command, there was no I here in the values. If you're familiar with, so what we did here, this assignment thing, we never assigned I to a starting value. Once we ran this loop, that is where the value of I got assigned to the first value, which was 10. And then it became 11, 12, 13, 14, 15, 16, 17, 18, and then it stopped. So the final value here is 18. So that's what it's showing you, that the final value is 18. Now, if you need this 18 for some purpose, then don't reuse I for the next loop. Call it J, call it some other word, give it some other variable. But if you are not interested in the actual value of I at any point of time, you can keep reusing I for all your works, right? For example, when I'm running this, then I is going to take these 3 values. First it's going to become A, then it's going to become L, then it's going to become O. So let's run this. Okay. Now if you saw here, since I did not have a bracket in this, once I did control enter on this line, it gave a plus sign because it said something's missing. You're still not completed with your command. So you're still missing something, and then you can just control enter the next line and it works. So again, for this loop, what output you got was what was expected, right? You just printed these things. Likewise, if I run this, it's still going to give me the same answer, right? So you can see both of these gave this exact same output. So they work just the same, but you have to be careful. Whenever you have multiple lines, you have to absolutely make sure that you're working inside a chunk. Okay, this is again, yeah, this is again the same thing, right? So whatever the vector is, you're printing the square of that. So we've done plenty of examples, so it's not very complicated. All right. So this is one of the most common ways in which you will end up using for loop. If you do, generally this is how it's used. Okay. Now we'll take an example of a nested loop. Okay. So we are again going to talk about these 2 vectors, vector 1 and vector 2. Now let's write it again. Okay. So what we start off with for I in vec 1. And then I have my curly brackets. I press enter. I can obviously have, let's say, print I here. And then I'm going to write. So now see, my cursor is still a little shifted. Now I'm going to write for again. I have my curved bracket again. I'm going to write another condition where I'm going to use vector 2. But now within this loop, I is already a very important term, right? So I don't want to overwrite I within a loop. That is going to create a lot of problems. So be very careful with that. Within the loop, when the value of I is still important to the working of the loop, go for a different counter. Let's call it J. So let's say J in vec2. And just as always, I'll have my curved bracket again. Curly brackets again. I press enter. And now you see my cursor is shifted a bit more, right? Because now this line is within two loops. It's within the inside loop. And now here I'm going to write print J. So that's it. Let's see what output you get. Can anybody think what would be the output here? What do you think is going to happen? We'll walk through it once we have the output, but what do you think is going to happen? If you can take a guess. Anybody?
Ma'am, I'm not sure. It will print vector 2,
Mm-hmm.
like A, L, O, 1, 2, 3,
Yes.
like in a column.
So vectored is not about columns or rows.
I mean,
Firstly, it will just
yeah.
print.
Yes,
Yeah,
yes.
firstly print the vector 1 value, then all the vector 2, then
Perfect.
vector 1, then all the vector 2.
Perfect. Absolutely. Yes. So you can all check. So somebody in the comments has already given. So that's how it's going to follow for all the values from 10 to 18. So let's try and run this. Right? So now you see this is what you get. So 10 and then ALO, then 11 ALO, so on and so forth until it's 18 ALO. Now, can you also tell me what's going to happen if I just swap vector 2 and vector 1 in this? What do you think this is going to give me now?
A and then vector 1, and then L and vector 1, and O vector 1.
Perfect. All of you. Okay, great. So I think all of you now understand that. Perfect. All right, great. So let's just double check. So yes, so we've seen, yeah, so it's working that the way we expected. So A and then all of these all of these numbers, and L, all of these numbers, and then O and all of these numbers, right? So, so yes, so the main thing that you should remember when you're working with loops is this condition has to be a finite thing. In for loop, it's very difficult to have an infinite condition, which is a good aspect of for loops. We'll see an example of what an infinite loop looks like when we talk about while loop in a minute. So that's important, the condition that you are defining. So this statement here, it means I in vec2 means it's going to take up the values in vector 2, whatever vector 2 is, right? And so once you have a condition written as you wanted, then you have these curly brackets. You have to ensure it's, again, even though you don't need it when you have a single line only. So for example, for this for loop, inside the for loop, there's just a single line. So you can do away with these brackets actually. But at least when you're beginning, it's always good to have that bracket. And once you have that bracket, it also, another thing to double check is like, it just helps you that if you have your lines, you can see these indentations happening, then you know that, okay, R is understanding what you want it to understand. And for nested loops, never ever have the same counter. It's a very common mistake that a lot of people do. I've done it many times, that I've used the same counter within a loop, right? So here I had different counters, I and j. And in this one, I'm using the same name because it doesn't matter. The order of I and j does not matter. It's the only thing is important. The only important thing is that each for loop has its own counters. Okay. Let's take just one more example. So I'm not going to write this here. What do you think would happen here? What sort of an output are we going to get in this loop? Again, these are very arbitrary examples. You can make these examples and, think what might this get, what might this give you, and then you see if you get that.
Ma'am, same like start with L, A, then vector 1, and then L, then vector 1, and O, then vector 1.
Yes, but this print is a little different. Yeah. So, right. So what it's giving you, as one of you rightly pointed out, oh, what happened here? I and J. Should... Interesting. Wait, let me. Why did it not print that? Okay, let's say if I do it this way, then it should, I'm pretty sure it should show. Yeah, okay. Okay, so what, as one of you correctly pointed out in the comments, so again, it's running the same way, right? Both of these loops, they're doing the same thing internally. So for every time that you have A, you get 10 to 18 run inside that. Then L also 10 to 18, then O 10 to 18. It's just I'm printing something different this time. So every time I am printing a new vector, which is made up of INJs. So this is my first INJ combination. Then INJ becomes this, and then INJ become this, so on and so forth. So again, there's no limit as to what all combinations you can do. You can have more loops within this. We'll take some examples where we have conditional statements within loops now. Okay. So we'll see that. Okay. Okay. All right. So let's say sometimes sometimes it may be possible to get the solution to a question in multiple ways. Okay. The first example between, so you remember last class we had talked about something called if, else, and if else. Can we somehow get A10? Okay, Ankit, yes, there is a way. So there is a function called paste or paste 0. So if there I do I comma j, so there I'm getting something like this, right? So if instead of this print, if I would write this thing, then we would get the answer that you mentioned. All right. Okay. All right. So you remember we talked about if, and then there was else, and there's this if else statement also. Right? We talked about these three things. Like these two we talked about in the last class, and this we're talking now. So the main thing between these two, the two five forms of if else, were that the first one cannot handle vectors. It only handles one number at a time. If else, this other one can handle a vector. right? So in some way, this one and a for loop can do the same task, but you really have to frame it properly. So we'll just take an example for that. Again, whichever of the two methods you use, the final outcome should be correct. It really does not matter which of the two is better, right? Very often when you're working with large data sets, it does become important that which of the two will give you a quicker answer. Sometimes one of them is much quicker than the other, but we will not be going into that right now. That's not the aim. Just remember that, but right now we'll just see what all different options are there. Okay, so the question that we'll address now is that we'll talk about vector 1. So for that, if you need to find the squares of numbers, only those which are greater than 15. But for the others, you find the square roots. If this is the setup, okay? So basically for numbers 16, 17, and 18, you should square them up. And for numbers 10 to 15, you should find the square roots. If that is the question, if this question was asked to you in the last class, this sort of a statement can work, right? So if you remember, the way it's supposed to be done is first you write the condition. So if else, vec1 greater than 15, then in first case, you write what to do if it is true. And in the second, like after the comma, you write what to do if it's false. So when it's greater than 15, you have to find the square. When it's less than 15 or less than equal to 15, you have to find the square root. So if I run that, you get this as the output, right? Which is perfect. Okay. Now, can you tell me how would we do this using a for loop? I can give you a hint, but just give it a thought. This is the question. So for all these vectors, using a for loop, you have to again do the same thing. If it's greater than 15, square them up. If it's less than 15, you find the square root. Any ideas? The ideas can be wrong, no problem. Okay, I'll give you a hint. You would still need to use the if-else statements, like one of this one. So you're going to use a for loop and you're going to use this one. Any thoughts on how you might solve this? Nobody?
Ma'am,
Ma'am, first
like,
we will just
Yep. Any of you can speak.
yeah, Saurabh, go ahead.
Hello?
ma'am,
Yeah.
what I'm
Yeah.
saying is for I in well one,
Mm-hmm.
vector one,
Mm-hmm.
after that we start the loop.
Mm-hmm.
Then we have, ma'am, just like if statement.
Mm-hmm.
So if well one is greater than 15, then vector one multiplied by vector two, else vector square root of vector one, and then we just close the loop.
That's you're almost there. Instead of writing vec1, vec2 inside the loop, you'll write I. That's the only difference. So this thing. You exactly said the same thing. Yeah, it's not this way. So you wrote for I in vec1, and then inside this loop, you'll have a conditional statement if. So if I, now each time, so just remember, once you're inside the loop, you don't talk about vectors. You're talking about one element at a time. And that one element is defined by this counter that you've defined. So that's I. And also if else statements always work with these work with single values. Yes. So that's, yeah, so it's vec1 in this case, but yes, that's perfect. Right? So what we have done is if I is greater than 15, then you need to do the square of I. Otherwise, you need to do the square root of I. So if I run the whole thing, I get the exact same answer as what I got before. Can anybody tell me there's a slight difference between these two answers? What do you think the difference is? Except the decimal places, that's not important. What's the difference between these two outputs?
Ma'am, last one is not a no, it's also a vector, but its order is one. Maybe
Yes, you're thinking on the right lines. So you're correct. The first one is a vector. So all of this is one single vector. First element, second element, third element, fourth, fifth, sixth, seventh, eighth, ninth elements. So you give it a vector and you get a vector as the output, which has 9 elements. In this case, you don't get a vector as the output. You get 9 independent values, which is why it says 1 every time. It's the first output in the first iteration. This is the output in the second iteration, output in the third iteration, but these are single outputs. They are not vectors, right? So, although that's not a very big problem, sometimes you may want the output as a vector. So now we'll see how that's done. But before we go there, did this thing make sense?
yes, ma'am.
Yeah, okay. So, all right. Fine. If this one's okay, then we'll see how to address this question of how to get a vector, right? So now in this example, definitely the if else seems to be really convenient. It's very quick, short, easy. But if there were multiple things, right? If you also wanted to print something in this, then it would become really complicated. I'm not sure how you can fit multiple lines here. Here it's easy. You can still print multiple things like hi, right? You can do that here. I'm just going to comment this out. But so again, the question comes, how do you combine the output in a single vector? So I'm quite sure there could be other ways to do this. This is one way that I have been using in my work. So I'll let you know that it's not very complicated, but there could be a different way to do it also. All right. So now what we are going to do is, now if we want the output as a vector, we'll define an empty vector initially. Okay. Or rather, we'll define a just a variable which we'll call it NA. Okay. So what have we've called that? Okay, let's call it L, and we'll say it's NA. Before we start off that loop, before we start this thing, we'll call it L, and you can see here L is NA. So right now L is neither a single value, it's neither a vector, nothing. Like it's just NA. It does not have any, I mean the length is 1, but otherwise it can take any form. It's not necessarily a single element thing. Now, okay, before we go there, let me show you something else. Okay, so it's a bit, it might seem complicated at first, but please try to bear with me. This is not a part of what you would have seen in the lectures, but since we are discussing on this topic, it's worth to go a little step forward, get a little more idea. It should not do any harm. If it's complicated, you can simply forget about it. But let's try for the next 2-3 minutes. Let's give it a try. Okay, now here when we are talking about vectors, we never talked about the position of I mean the position of the element, the value of which is taken by I, right? So let me tell it to you somewhere here maybe. Okay, we'll take a simple example of, again, just vector 1. Now if I say for I, in 1:, length of vec1. Okay. Now it looks a little different, but you see I, it's still there. In is also there. Instead of writing vec1, I've written this thing. Can you tell me? So vec1 was a vector with values 10, 11, 12, 13, 14, 15, 16, 17, 18, right? Now I'm defining something else. What is the highlighted area here? What's the value that this highlighted area is going to give you?
Maybe it will print 1, 2, 3, 4, 5, 6, 7, 8, 9.
Perfect. Exactly.
Length of vector.
Yes. So it is length of vector is the final value. One is I have written 1 as the starting value. And you know, we had come across this when we were initially talking about vectors, right? If I just simply write this value here, it's anything, right? You can just write 1:9 also. But since we are talking about vector 1, we'll write it in terms of vector 1, right? So instead of I taking up values of vector 1, I is going to take the indices of vector 1 now. Does this statement make sense? So instead of I taking values of vec1, it will take indices of vec1. Right? So this is understandable. Now what I can do is I'll do the same thing and I'll just write now. So first, when we go into the loop for the first time, the value of I is 1, right? Now, if I want to print the square of the first value of I'm sorry, the square of the first value of vec1, how do you think I might be able to do it within this loop? So I is 1 right now, but I want to print the square of 10. How can I do that? You've seen this before. It's just presented in a different way. So I is no longer, yes, sorry.
Ma'am, SQRT and this bracket 1, 1. I mean, like a vector.
Yes, okay.
So we are giving a position. So vector 1,
vec1 I.
1, I is.
Yes, so not comma. Comma happens in when you're talking about matrices. This is vector. So it just has one dimension.
I square, yeah.
Yes, yes. So if you're talking about square, then yes, instead of this thing, you can just have a square here. So so now this statement, like this loop and this loop, let's run it again. So this one, we saw it's going to give us squares. Now let's run this thing again. So you see, it's also giving us exactly the same output, right? Definitely looks more complicated because instead of taking values, you took indices. And then now here you are recalculating the value from this index. So of course, it's not very useful, but at least now you know that this is also a way it can work. Now we'll go to that complicated loop that we just skipped right now. Again, it's not very, very important, but let's see. So again, what I've done here is, again, it's the same thing for I in 1:, length of vec1. So again, so I is going to take values 1 to 9. And inside this bracket, so basically why I've done this is I now have a count. I now have a count that the loop is learning once and then second time and then third time, fourth time, eighth time, ninth time. When I was taking values 10 to 18, I did not know what's the number of time that the loop is running, right? But once I have this index, I know it's running from 1 to 2, then 3, then 4th, 5th, 9th time. Okay. So once I have that, I can do the same thing. So we just saw that example, right? If it's greater than 15, square it up. If it's less than 15 or equal to 15, you find the square root. So again, we're doing the same thing. There's this if-else statement. And again, so the highlighted area here is the value. So vec1 at the ith position. So let's say first case it was 10. So if a 10 is greater than 15, what do? You do this. We'll come to it. Otherwise, you do this. Then again, for 11, for 12, for 13, every time you'll run either line number 94 or you'll run line number 96. Now, let's say we're talking about 10. So what happened when 10? So of course, this is not true. 10 is not greater than 15. Yes. L is NA right now. So we'll just come to what's happening here. Give me half a minute more. So when we executed this is false, right? So we go to else now. So this is going to get executed. Now, what is happening here is the right side gets assigned to the left side, right? That's the assignment operator here. So we are doing the square root. And of course, square root of 10, that's what it's giving us, whatever it was, 3.16, for example, right? Now that you are assigning to the ith index in L. I was 1. Okay. So let's try to see it again. So in the first iteration, I is equal to 1. When the loop is running for the first time, right? When loop is running for the first time, then vec1 this is equal to 10, right? This means that the condition is false. So you go to the else condition, else chunk, and then there you do a square root. So there you get 3.16. And then that you are assigning to ith position, which is L1, which is the first element of L. So right now L is nothing, but then you have L is 1. Like the first position of L becomes 3.16. Then we go back to the loop. I becomes 2. Vec1 I becomes 11. This thing still stays the same, but now you get values assigned to L2. The loop keeps happening until, let's say now, if once I becomes, let's say, 7, once I is 7, like so on and so forth, right? So it's going to go multiple times. And then when I is equal to 7, can one of you walk me through this? What do you think is happening? When I is 7 here, we go inside, we go to line number 93. What's happening here? What's the value of vec1 at the 7th position?
16.
16, right? So that's 16. So does this statement become true or false?
False.
No, true. 16 is greater than
Okay,
15.
16. Yeah. Sorry.
Right? Right. Yes.
Yeah.
So it's true. So you go into the if part itself, right? So then you do a square, right? So that's 256, right? And then
Yes.
you assign that to the 7th position of L.
L7.
L7, right? So now L is building up. L is becoming longer and longer. So let's try and see what's happening here. Now keep an eye on what L is happening. Like what's L here? It's NA right now. Now I'm going to run this loop. L becomes a vector. And if you take a look at what L looks like here, so now L is exactly the same thing that you saw initially from the if-else statement. Remember? We ran this. So there you directly got that output. Here, after doing so much of work, we got this output. So again, in this example, it may seem that the loop is very, very tedious and that if-else simple was very simple, one line. But again, it's a matter of your preference. And in this case, it was a relatively simple thing to do. I mean, there were just single options. There were not multiple things that we are executing. So the if else work better, but at least now you know that there is this option also. So you can make that judgment whenever this sort of a thing comes up again. All right. Okay. So that's the first major bit of this session. And if you've understood this, that's really good. If not, do take a moment to like once, but I'll share this with you at the end of this class. Take a look, try to write again. Practicing really helps. In R, I think the best way to learn is to keep practicing, make mistakes, figure out, troubleshoot them, and then you'll really remember what to do. Okay. All right. So we'll take some more examples here. We talked about this break and next statements here. So again, we'll do the same thing. Let me simplify this back to that version. Okay, right. Hmm. Okay, now this is the question here. So again, we're talking about vector 1. So if that number is greater than 15, you find the square of it and you also print the word NPTEL. If it's not greater than 15, then you just print NPTEL. Okay. So, or okay, let's take another example here. Okay. Okay, I'm just making up another example here. All right. So first of all, this case. So the number is greater than 15. We find the square and we print NPTEL. Otherwise, we just print NPTEL. That means NPTEL needs to be printed, right? That is definitely going to happen. So you have to write it outside a conditional statement. It cannot be in the conditional statement, right? Because conditional means or, right? It's just if else. So since NPTEL has to be there, it'll be within this loop. So it's within this bracket, but it's not within the brackets of if. It's not within the chunk of if. So does this command, this loop make sense to you? So we'll just see what output it gives us. All right. So the question was that square it up and print NPTEL if it's greater than 15, but for numbers up to 15, you just print NPTEL. So again, the loop was written in a very similar way as we've been seeing so far. So when I was 10, this is what you got. Then 11, and then 12, then 13, 14, and 15. And then when it was 16, you got this as the output. And then this when it was 17. And then this when it was 18. Right? So it's working the way we want it, right? Just let me know if it's all right. Okay, if you're not letting me know, that I'm assuming it's understandable. I hope you can still hear me, right?
Yes, ma'am.
Okay, all right, good. Okay, can you tell me what difference did I do here from the previous set?
Here, ma'am, NPTEL will be printed every time, like whatever the value.
So in previous case also it was printed every time. So because NPTEL,
No, here will be like first loop is yes. So then, like, if any value of I,
Uh-huh.
it will give a NPTEL,
Uh-huh.
and then after
Yes.
before the number, yes,
Yes.
NPTEL and the square.
Yes.
Yes.
So here you see what happened is it was
Mm.
number and then NPTEL, number, then NPTEL, number, then NPTEL. Now in this second example, you got NPTEL, NPTEL, and then NPTEL and the number, NPTEL and the number, NPTEL and the number. Right? So that's a very minor difference. But just remember that the positioning of your outputs within the loop can affect how the output look like. Right? So again, these are very minor things. Mostly you learn all of this as you start writing commands yourself, but this is just for your information here. Okay, now I have so now we actually come on to that other question. So if the number is 15, right? So then you find the square and then you also print NPTEL. But if the number is not greater than 15, then you don't do anything. So this is one way of writing that command. So if the number is greater than 15, this is what we had written previously also. And this NPTEL was there before also. What I did now was that I added an else statement and wrote next here. So, yep. Okay. Ankit, I'll come on to your question in a couple of minutes time. Okay. So, yeah. All right. So what is happening here is if I is not greater than 15, if it's less than 15, we go to else and then this next comes up, right? So next means that you skip whatever's written after this. Whatever's written after line number 130, you skip that and you go back to the line number 126 and you do the next iteration. And then you go ahead. If it's still less than 15, if you're still going into the else set, then again, don't execute the rest of this. So basically, it's going to print the same thing. If it's greater than 15, find the square and print NPTEL. Otherwise, don't print anything. Now, okay, I just made this a bit complicated. I don't know why. Okay. So, the other option here also gives you the same output. Instead of writing that next statement, we could just write the square and NPTEL in the same chunk of if, right? Because both of them are to be executed together. So again, this is a very complicated example, but I could not think of a better example right now. So you'll have to bear with me on this. But this is just to give you an understanding of how next is working. Next is doing that if you come across that next line, the word next, then you do not execute whatever's after this. You go to the next iteration. Okay. Ankit, can you elaborate on your question? I'm not sure if I've understood this. Is this a question or were you referring to this thing example that we just talked about right now? Okay. All right, fine. Okay. I do have a few more examples here, but in the interest of time, I won't be going through them right now. You will get these things. I think you've understood how broadly all of this is working. Take a look at what these things are doing, right? So this is just for practice. Okay, try to see what this is doing. We can discuss this in the next class if there's any confusion, but these are just random examples. Okay, so you can see what's happening in them. All right, so that brings us to the end of the for loop discussion. So that is one of the main loops that is used. There's another loop which is called the while loop. Again, just as any loop, you need to have a condition which you write within that bracket. Okay, we'll see this in more detail right now, but you can see that there is a condition right there, right? There's also this chunk inside of this where it's something's happening. But now we are not exactly talking about a vector anymore. Okay. Here, I is not taking up any values from vec1. Maybe as an example, what we can do is, let's take this example. Okay. So let's say instead of actually referring to vec1, we are pseudo referring to vec1. Now what we are doing is we're initializing, this is called initialization, a condition variable, which is also going to be like a counter in this case. So we have defined I to be 10. So let's first run this. So I becomes 10 here, right? And then we are saying that while I is less than 19, okay, you do some tasks. As soon as I becomes 19, you don't do the task anymore. But until I is 19, you do it. So you have a starting value, you have a final value, but you did not tell it yet how to go from the start to the end. Do you go in steps of 1? Do you go in steps of 1.5? Do you go in steps of 2? Do you go negative? We've not written that. So that goes into the body, into that chunk. Okay. Okay. So what's happening? We first have IS10. We go inside this loop. We check the condition. Is I less than 19? Yes, it is. Okay, let's do something here. Okay. If it is less than 19, you print the value. And then what you do is you increase it by 1.5 and then you save it back into the same variable. You're overwriting the variable here. The counter is overwritten anyway inside the loop, right? So that's important. And then you go back to the start, you check. So it was 10, now it's 11.5. Is 11.5 less than 19? Yes, it is. So you do this again. So after 11.5, it becomes 13, then 14.5, then 16, then 17.5, and then it becomes 19. And then 19 does not get printed because 19 is not less than 19. So this is what we're getting here. So we initialized. So it printed 10, then it increased, checked again, 11.5, 13, and so on, just like we discussed. Does this make sense?
Yes.
Okay. Now, just another very minor example. What do you think would be the difference here? Is the loop going to run a different number of times? Is it going to print something different? What's going to happen?
It will print something different.
Okay.
That's
Yes.
like it will print 19 and it will not print 10.
Very good. Correct. It's okay. All right. Yes. So what we did was when I was 10, it got in, but then before printing anything, it got increased to 11.5. And then that got printed. Okay, so on and so forth. Then it was 17.5. it checked, it went in, it became 19, it printed 19, and then it went up and checked. So there was no, so then 19 did not go in. So you rightly pointed out, the loop is still running the same number of times. The position of the print statement is not affecting how many times it's running, because print is not changing anything, right? The condition, the main factors, which were this initialization, this condition, and then this, this increment line, they're still there. It's just that the print is now something else. So instead of that 10, we're now printing 19, as you rightly pointed out. All right, perfect. So again, this is another example where positioning within the loop can have some effect in your output. So you need to be a little careful. And then let's just take one more example. So now I initialize to I, and I say, let's say I'll just write, well, while I is less than 10, but I do not have an updation statement. I'm not doing any increment or nothing. Okay. So we'll see what's happening here. Okay. Now you see, it's just printing 1 and 1 and 1. And you can see that the stop symbol doesn't go. So it means it's still printing something. You can't see it, but it's just printing one infinite number of times. So we'll just stop it from here. It stopped, but you see, it's just printing 1, 1, 1, 1, 1, nothing. Okay. So this is something you should be very cautious of. This problem will not happen in the for loop, right? Because for loop, in that you're already starting off with a vector, right? But in a while loop, you are very much dependent on this statement being, like this statement is very important. Okay. All right. Okay. We will come on to,
Ma'am, I
yes,
have a little, just for the clarification in the
yes,
previous
yes,
one. Like here we are printing I. That means like a value of 1. Like
yes,
I, whatever we have defined I.
yes,
But
yes.
let's say like if we are, I'm not sure, like I will do, if let's say I plus 1 or something, I plus 2, again it will be infinite, or it will stop sometime.
Good question. So what is happening here is we are printing like something like this, right?
Huh.
So what is happening is, you're right, we are printing 2 here or whatever, 3 maybe.
Mm,
I
mm.
is 1 plus 2, but the value of I still remains 1. We are
Okay.
printing 3, but every time the value of I is not changing. What was happening here is we are reassigning that value to I. We are not just
Okay.
saying
Yeah.
I plus
Yeah.
something. I is
Yes.
getting
Yes.
updated.
Yeah.
Oh, yes.
Thank
So
you.
in this case, so you see it's printing 3s now.
Yes. Yes. Yeah.
Okay. But yes, this is a very good question, and this is how, we learn.
Okay.
Okay. Okay, we'll come on to the repeat loop in a little time. I think I missed writing what was supposed to be written here. So let me remember. Um, Again, the repeat loop is not super common in R, because you need to initialize something also, which we did in the while loop. You need to write the condition. You need to update it, and you also need to terminate the loop. So we'll come on to that. Okay, let's actually try. I think I've forgotten the syntax of this. Okay. I'm really sorry about this. Let's move on to the next part right now, and maybe we can come on to it later. Okay, fine. So the main two kinds of loops, the for loop and the while loop, that's done. Now we move to functions. So we've been talking about functions the whole time. Anything that starts with a name, that's a loop, that's a function. So print is a function. while is a function, if is a function, like for is a function, sum is also a function, right? All of these are functions. Everything that we've been talking about, C is a function, matrix is a function, seq, seq, that's a function. These are predefined functions, right? You don't have to define them yourself, but now you can make functions on your own. So currently what you're doing is you're directly running the function, right? Whatever function it is. Now, when you're defining functions on your own, it's a two-step process. You write it, you type it down, and then you run the function to tell R that, okay, I might want to use this function. So you run it, and then you use it. So we'll see what we are talking about right now. So these are just examples of functions that you've seen. This is not new. So this is the syntax. This is the way you are defining. So you give a name. So sqrt is a name, right? Just like that, you call your function something. So I'll call it my func. And we'll have this assignment operator, or you can also have the is equal to symbol. And then function is also a function, by the way, right? Okay, that's a nice thing. Okay, so function, and you have the curved bracket, and function also has a chunk element to it, so you have the curly brackets. So now we'll see. Now think about let's say about the sum function. What you're writing inside the bracket, they are the arguments, right? They are the inputs that the function takes. And it does something internally. It does adding, right? It does 1 plus 4. That's what this function is doing, right? Again, what is sqrt doing? It is taking up a number. So some function can take multiple inputs. It can take 2 inputs, it can take 5 inputs also. sqrt, typically, it can take a vector, but typically it's taking one element at a time, right? So in a function, you have to tell how many inputs is your function going to take. Can it take just one input? Can it take 2 inputs? Can it take 10 inputs? You call them something. You call them X, Y, A, B, C, D, A1, A2, A3, A4, anything. So for example, the function that I want to define is I want to find the square of a number, then add 10 to it, and then find its square root. Suppose this is what I want to do in my function. I can do it this way, right? I can do a square, then I can add 10, and then I can find a square root of, let's say, 20. I also want to do it for the number 40. So what happened here is I had to write the entire thing twice. I can mess up brackets somewhere, right? It's a little, it is a bit something to remember. So what I can do instead, I can define my own function. If I know I'm going to use this very often, I define my own function. My function is going to take one input at a time. I'm calling it X. And what do I want to do with that input? I want to square it. Then I want to add 10. Then I want to find the square root of it. And now I want that once it does this, so whenever you're running the sum function, it returns an output, right? It returns. It does not keep the calculation to itself. It gives you back that answer. So here also, I'm saving it in a temporary variable A, and I'm returning that variable A. So this is an important part. Okay. We'll see it in a little more detail once more. So right now you see in your global environment, whatever we just talked about is there. Now what I'll do is, this is where I'm defining my function. I'm going to press Control Enter here. So now you see my function has also come up as in the environment. Now R is able to understand what to do. So just like you have the sum function, now I have the my function. And now if I want to calculate, so it looks like a normal function, right? Normal, something that an inbuilt thing in R, right? You just type in, you either have a named argument or you write it without the name. It doesn't matter. Once I run this, you see I got the output. Once I run this, I get another output. So what it's doing is it's squaring it up, it's adding 10, and then it's finding the square root. Right? Is this making some sort of sense? So
Yes.
again, what we did here, we defined the function and we run it, right? So here we have defined the function, and then once we were running it, our function came up here in the global environment, and then we can simply use the function. We can use it now. Here we are using the function. Now, sometimes if you just, if always you want, let's say if always you want the thing to give you the, if you always want the calculation to be with 30, you're not giving the user an option to calculate something as per their own wish. You don't have a variable at all. Don't have X, don't have anything. There's nothing here. So it's always going to give you a fixed value. If I run my func2, it's just giving me a fixed value every time. Now, as a practice, we will do it right now. Can you help me write a function where I want to take 3 inputs from the user? I want to multiply the first 2, and then I want to subtract the third number from it. Can any of you tell me? I want to call it my func3. So what do I start writing?
Ma'am, please repeat the question.
Okay, so I want to define a new function which is going to accept 3 inputs from the user. It's going to multiply the first 2 inputs and then subtract the third input from that product. So this is the syntax of the function, right? So I want to call it my func3. I want to accept 3 inputs from the user. So what do I call them? Any 3 variable names.
You can take any 3, like if you are doing like a vector, then so vector 1, vector 2, and another one variable.
We are not taking vectors. Let's not take
Okay,
vectors
so
right
then
now.
X, Y, Z.
X, Y, Z.
Okay, fine. Let's take X, Y, Z. Okay. So now inside I wanted to find the product of the first 2 and then multiply. Nice, very nice, perfect. So, yep. So let's define a new variable. Let's call it V. And what I'm doing is I want to find the product of the first 2 and then subtract the third one. And then I want to return this output. That's it. That's my function. So I defined it. Now I want to run it. So I'll press Control Enter. Now this one comes up here. Now let's say I can choose any 3 variables that I want to find. So let's say it's 100 and 412. And then I want to subtract, I don't know, 125 or 215, whatever this is. I press enter, I get some value. It's done. Right? I can do it for some other example also. So 3 and -2 and 10. So if I run this, I get the output. So 3 into -2 is 6, and then, sorry, -6, and then -6 minus 10, that's -16. Yeah, so this is, so yes, so functions are used to accept one or more inputs from the user. So we've seen these examples, and these inputs can be different each time, right? So we have seen different inputs. All right. Okay, why do I have more while loops here? Okay, I think this is also for your example, just for your practice. So just one final thing is left, the sequence thing. I'm not sure, we touched upon this definitely initially, but we did not go into a lot of detail. So again, the main thing is when you want to generate a sequence, there could be several ways in which you can generate a sequence. One is, of course, a starting point and an ending point. Where do you want to start and when you end? You can also specify in how many increments or decrements do you want to go. So that by that by thing is, do you increase it by 1 each time? Do you decrease it by 1? Do you increase it by 5? Do you decrease it by 3? So that's +1, -1, +5, -3, and so on. Or you can just specify, so something like this. Okay, let's not jump. So this one is basically saying that you have a from, you have a to, you do not give anything else. So by default, it's going to do in increments or decrements of 1, that it will ascertain on its own. So when it took 1, 10, it increased, because when you want to go from 1 to 10, you have to increase. That's understood. And when you write 10 to 1, it understands that you need to decrease, but it's always going to do it in steps of 1, whether that's +1 or -1. There's this option that you can, maybe you don't want to specify the from, you don't want to specify a starting point. You can just specify an ending point. You can specify the increment, decrement, and you can specify how many do you want. So you went to 10, you were increasing by 1 and you just had 3. So it's going to be 8, 9, and 10, right? It's not different from 1 to 10. It's exactly the same thing. Yes, this is exactly 1 to 10, and this one is exactly 10 to 1, like 10:1. So, like many things, there are multiple options in R. So for doing the same thing. So generally what happens when you're talking about these simple examples, where it's just a simple 1 to 10, you definitely, this 1:10 thing is more convenient. But when you want to say you want to go in increments of 5, in that case, instead of writing this, you'd much rather, let's say you much rather write, I don't know, 2.5 here. Oh, sorry. Yeah, this one, right? All right. Okay. One final thing in the sequence thing. So we talked about that you can have named arguments and then you can have just positional arguments, right? So here we did not write names. So it was understood that the first thing is from, the second thing is to. Here in this example, we did not have a from. We just had to by length, which was enough. Now, if I write the same thing, which is 10, 1, 3, R does not understand that it's to by length. Instead, it understands that it is from to by. So which is why you get this error that the wrong sign in by. Because when you're going from 10 to 1, you don't go in increments of 3. You can go in decrements of some number. So all in all, there are these 4 main arguments in the seek function: from, to, by, length. You don't need all 4 of them. Sometimes just 2 of them are enough. Sometimes you need 3 of them. But depending on which 3 you are using, it's better to have the name rather than relying on just the positions. All right. These are just some examples of more loops. Take a look at them. Last thing that I want to discuss is there are some questions in this assignment They are again based on things we have seen in the past, but I would just like to give you a quick recap. So again, we're talking about, let's see, we're talking about two vectors here. Vector capital X and vector capital Y. One of them has 6 elements, one of them has 5 elements. Can you tell me what is this? What would I get if I run if I run line number 299? 7, right? So it's the fourth element. So that's 1, 2, 3, 4, that's 7. Okay. If I run Y5, that's 5, right? Okay. If I run Y minus 3, what do you think I'll get? Y minus 3. So Y minus 3 means you remove the third element and give me everything else. Okay. So it's going to give me 1, 2, 4, 5. It's removing the third element. Let me take X as the example instead. If I remove X minus 3, what do you think I'll get now? Think about it carefully.
Um, 3, 0, 1.
It's not subtracting
It
3.
will
Um, uh,
remove 4.
yes. So the thing is, it's removing the third element. It's not subtracting 3. It's not taking the third element. It's removing the third
I
element
thought
from the
like
vector.
you're writing x3 minus 3. I mean bracket then minus 3.
Nine. So it's, yeah. So what you said would have been this, X minus 3.
No, ma'am, same way, like x minus 3, it's a bracket, and then right, minus 3. So then what will be? X bracket minus 3.
Inside the bracket,
Yeah,
outside the bracket.
inside the bracket minus 3,
Uh,
and then outside the bracket minus 3.
okay, we'll come to this also. So first of
So
all,
that's what I was thinking is this will be printing.
okay. So
Yeah.
X minus 3 simply means you're removing the third element. So that is X. So this is 6, then 3, then 7, then 2, then 9. So not 63429, but 63729. Right? This one. Now, what you just mentioned about this. So now after this output, you also subtract 3 from all of them. So you get 6 minus 3, 3 minus 3, 7 minus 3, 2 minus 3, and 9 minus 3. But this is very
Yes.
complicated. But yes, this is what it's
Yes.
doing. Okay. Now, can you tell me what is this here?
Two.
Yes. Okay. So x5 means the fifth element of X. And then you are taking the second element of Y, which is 2. All right. So let me do something here. Okay, what would it be now? So it's Y2, but that's 3. Right? I've just updated Y just to confuse you and more. But okay. All right. So there are questions like these in this week's assignment. Be a little cautious. They can be confusing at first, but keep in mind that the square bracket is always for the index. So when the index is written without a sign, you are taking that index into account. When the index is written with a negative sign, then you're removing that index and everything else stays the same. But sort of you remove that. So the vector becomes shorter now. Okay. Like in this case, we had a 5 element or like a 6 element vector, but then we remove the third element. So now there are just 5 elements. Okay. All right. That I think brings us to the end of this class. Do I have any questions for you? Okay, I think I just have 3 or 4 questions for you. Okay, quickly, what would happen if a variable is not initialized before the starting of a while loop? What do you think? It's just a question to to test your understanding. So you can unmute yourselves, you can type. Okay, that would have been nice, but no. So if the variable is not initialized before the starting of a while loop, it will give you an error. It will say, oh, I don't know what happened here. For example, let's say this one. Okay. Typically, let's just say, okay, I'm removing I for now. So I is not initialized, right? I did not have I before I'm starting this loop. So if I run this, it's just going to say error, object I not found. Or if I was there, it would have taken any existing value of I, which is even more dangerous, right? Because then you would assume that the loop is running, but I did not take up a value. So which is why in for loop, this problem does not happen. So I am a little more inclined towards using the for loop. But again, both the loops have their own advantages and disadvantages. So if the variable is not initialized, if it's not there in the R environment at all, then R will obviously not be able to find it. But if it's there and if it has some random value, then it's just going to start with that. So which is also not good. So you have to be very careful that in the while loop, you have to initialize the variable. Okay. What about the second question? So what would happen if you initialize the variable again inside the while loop? So you initialized it outside and then you again initialize it. You again said, okay, I is equal to 2 inside the while loop. Can you think what might happen then?
Again, error or infinite loop?
Infinite loop. Yes, generally it's going to be an infinite loop. Because I was supposed to keep increasing, but
Yes,
you
in which
fixed
will
it
do.
to a particular value inside every time. So it's just going to stay stuck, right? Okay. All right. How many arguments can a function have? A function that you are defining or the function that you are using so far in R, how many arguments can it have? Or how many arguments does it have?
Argument, ma'am, only one.
Think about it again. You just defined a function with 3 variables, right? X, Y, Z.
Okay. Then to
Any number.
any number.
Yes.
Yeah.
Okay. These questions are just to confuse you. So it's okay. All right. And I think yes, the last question. What do you think would be the output here? The seek string. So it says you go from 1 to 10 in decrements of 1. In steps
Thing,
of 5.
ma'am, I don't know.
Error.
Warning.
Error.
Okay. Yes, it's going to be an error. Because you can't
Okay.
grow, you can't go from 1 to 10 in by decreasing, right? So remember, R gives a warning when it's able to give you an output, but it's not sure if the output is correct or not, right? So warning is accompanied with a output. But in this case, you cannot have an output, right? You can't
Yes.
go from 1 to 10 while decreasing from 1. So it will give you an error. You can try this, but it's going to give you an error. Okay. Yeah, I think I don't think there are any more questions. Do you have any doubts from assignment 5 that you want to discuss? But if not, then that's the end of today's class. All right. Okay, cool. Again, if there are still any more questions, you have the Q&A forum in the NPTEL page that you can always go to. You'll always also have one session on Tuesday that the other TA is taking. So you can still ask questions there. But if everything's clear, then I'll see you all next week. Don't forget to submit your assignment on by Wednesday. And yeah, so we're done with half the lectures, half the course is over. Most likely there would be a couple of weeks time between the class for the 12th lecture and your exam. So in between, I will conduct a revision session and we can go over some of the things that might be confusing, or we can solve some questions. So we'll come to it once we're closer to that date. But yeah, so we have at least 6 more sessions from the lecture themselves and 1 revision session as well.
That exam will be online, right?
Yes, the exam is going to be online. And you will not have access to R there. So the questions are going to be similar to what you see in your assignment, but you will not be able to type in those and get the answer. So, which is why when you're solving the assignments, it will be a good practice if you try to solve them on pen and paper without the use of R, and get an idea if you're solving it correctly. And then if you know it's okay, you can double check with R.
Is there any software or only how that exam will be happen?
The exam will
NPTEL or
be, no, it'll be like if you've appeared for any other computer-based test, it's going to be very similar to that. You'll have a screen, like questions on the screen. I think you'll have access to a scientific calculator, but you will not have anything else. Like you can solve on pen and paper. You'll have a rough sheet given to you during the exam, but no other software can be opened on that computer.
all right.
Yep.
Mm.
All right. Okay. All right. Thank you so much, everybody, for joining in. And
Thank
I'll see
you.
you next week then. Thank you. Bye-bye. Good night.
Bye.